Hey class, so in this video I'm going to talk to you about mole conversions, but instead of just talking about the regular mole conversions that we've been doing between mass and moles, we're also going to talk about moles to particles. And so that involves atoms, molecules, and formula units. And yes, because of what you're learning now, you get to say FU in class for formula units. Okay, so here's a diagram that should help you understand what you've been doing and what you're going to be doing. So moles are in the center, as you can see, right? And to go to grams, you have to multiply by molar mass. Think about it. When moles is the given, and you're trying to solve for grams, you put moles on the bottom, and you put grams on the top, and you notice that you're multiplying by the mass, because the mass goes right there, right? Here's the given, here's the answer. When you want to go the other way, when you want to go from mass to moles, you divide by molar mass. That's because when you start with grams and you end up with moles, the grams goes on the bottom and the moles goes on the top. So you're actually dividing by the mass, the molar mass. Again, here's where the given is and here's where the answer goes. And similarly, when you go from moles to particles, as you can see on the right side here, when you want to go from moles to particles, you're going to multiply by Avogadro's number. Remember, a mole is this really large counting number because atoms are really small. To be able to count atoms, you have to count a lot. In order to see atoms, you have to be able to count a lot of them. That's Avogadro's number's worth, right? 6.02, but you move the decimal point 23 times to the right. And if you want to go from particles to moles, you divide by Avogadro's number. You just got to get the units right. And that's the units are this atoms, molecules, and formula units. So let's quickly review mole conversions. So you see 25.3 grams of O2. So you write 25.3 grams of oxygen. And you're solving for moles of oxygen. I'll run out of space here. It's going to write it at the bottom. And you put grams on the bottom and moles on the top. And you know that the molar mass of oxygen is 16, but 16 times 2 because of the 2 oxygens. So you divide by 32. So now I get my calculator out. And I do this division. So 25.3 divide by 32. And you get your answer. So you need 3 digits, so the answer is 0.791 moles of oxygen. So that's how you do mole conversions last semester. So now we are going to talk about the new kinds of mole conversions. Basically, how do you go from moles to particles, for this right side of this diagram, from moles to particles and particles to moles. So first, you have to know the 3 kinds of particles. So an atom is when the symbol is just by itself. So for example, I was going to do a mole conversion with only calcium. I would write Ca right in my setup in my calculation, and I would just write atoms of Ca because basically you're just categorizing the kinds of particles that you have. Ca, it's only one atom, so you write atoms. If the particle that you have has one of these atoms in it, right? These are the nonmetals. If they're all nonmetals, then it would be a molecule. So for example, carbon dioxide, or oxygen, or sulfur trioxide. See how each one of the atoms in each of these particles is they're all nonmetals? Well, then they'd be termed a molecule. Now if you have a metal and a nonmetal together, that's an ionic compound, and that would be called a formula unit. So for example, if you have Ki or NaCl or MgBr2, any one of these would allow you to see there's a combination of a metal and a non-metal, right? K is on the left side of the periodic table, it's a metal. I is a non-metal, because it's on the right side of the periodic table. Na is right there, it's a metal. And chlorine is a non-metal. Magnesium is right here, it's a metal. Bromine is a non-metal. So metals and non-metals together make ionic compounds, which would be termed a formula unit, or in class, as you can say, you can write Fu, but only as it relates to chemistry, of course. So, how many particles are in 2.73 moles, 2.73 times 10 to the negative 2 moles of F2? So, you write 2.73 times 10 to the negative 2 moles of F2. I put moles on the bottom, and I'm putting particles on the top. But I know what kind of particle F2 is. So you see that there's two F atoms, right? So it's not an atom by itself. It's two of them, right? So it's F2. And since they're both nonmetals, it would be molecules. So I'm going to write the word molecules up here. Equal sign. And you got to know how many molecules are there in a mole. Remember, a mole is a counting number. It's always Avogadro's number. So it's 6.02 times 10 to the 23rd. And I can't write it here on the right side, so I'm going to write it at the bottom. I'm going to solve for molecules of F2. So I'm going to type this into my calculator here. So it's 2.73 times 10 to the negative 2 times 6.02 times 10 to the 23rd. Right? It's multiplied because the Avogadro's number is on top of the fraction. And there you get your answer. You also want to be able to change it into scientific notation. So there's my answer, which is 1.64 times 10 to the 22. 1.64 times 10 to the 22 molecules of F2. So that's how you do mole conversions, using particles and mass and moles. So again, this figure really helps you do that. When you convert from moles to mass, you want to multiply by molar mass. When you go from mass to moles, you divide by molar mass. When you go from moles to particles, you multiply by Avogadro's number. And when you go from particles to moles, you divide by Avogadro's number. So please make sure that you, after you take notes with this, you practice on the mole conversions 4 worksheet that I gave you today in class. Thanks. Have a good one.